Hey there, everybody. Today we are looking at section 6.6, which is all about properties of trapezoids. All right, so a trapezoid is the one shape in this chapter that we are specifically looking at that is not a parallelogram. All right, so the big thing again that you need to remember is it is not a parallelogram. So the 5 parallelogram properties that we did, the extra properties with the rhombus, the rectangle, the square that we did, with all that within the last 4 sections, none of that applies to a trapezoid. Okay, so a trapezoid is a quadrilateral with one pair of parallel sides. Okay, the other pair is not parallel. So my parallel sides are called the bases. Okay, so you can see here my parallels are the blue sides. They are my blue bases. All right, and the pair of sides that are not parallel are called my legs. Okay, so the legs of my trapezoid are the non-parallel sides. The parallel sides are called the bases. Now, on either side of the base is a base angle. So basically, what's kind of weird about this is all 4 angles are base angles. But when we look at them as a pair, all right, these are a pair of base angles. These are a pair of base angles. We don't look at them like A to B. Does that make sense? So we're looking them as a pair, okay? Now, the next thing is that if those legs are congruent, all right, then we have what is called an isosceles trapezoid. So again, the bases are not going to be congruent, but the legs will be for an isosceles trapezoid. All right, the next thing that I want you to see is that when we're looking at any trapezoid, okay, if these angles or these sides here are parallel, okay, so if we kind of come over here to the side and sketch, what do I know about this angle here and this angle here? Okay, if we're remembering that these lines are parallel, we should remember that these 2 angles are same side interiors, so they are supplementary. All right, so that means the angles along the legs are always going to be supplementary. They're always going to add to 180 because those bases are parallel. All right, so if you have any questions, go ahead and write those on your notes now. And let's take a look at the theorems that are associated with our isosceles trapezoids. Okay, so these are just specifically for my isosceles trapezoids. All right, it is not for all trapezoids. So when I have isosceles trapezoids, those pairs of base angles are congruent. So remember when we had an isosceles triangle and my base angles were congruent? This is the same thing, except now we've basically just cut the top off of the isosceles triangle to make the trapezoid. So these 2 angles are going to be congruent, and these 2 angles are going to be congruent. So remember, that's those pairs of base angles. Okay? I also know the converse of that is true. So remember, your converse is simply switching what you know. So if we say, hey, I have an isosceles trapezoid, that means I know base angles are congruent. The converse of that is if I have a trapezoid with base angles congruent, then I know it is isosceles. So if these 2 angles are congruent, or B and C, it doesn't have to be the bottom pair, it could be the top pair, okay? If one of my base angle pairs is congruent, then I know my trapezoid is isosceles, okay? The last property for isosceles trapezoids is that it does have congruent diagonals. So remember when we did rectangles, I told you guys it was really important that you prove parallelogram first, because a parallelogram with congruent diagonals is a rectangle. This is why we have a non-parallelogram with congruent diagonals, and that will be an isosceles trapezoid. So it is really important that you understand the difference. All right, and if you have any questions about that, make a note of it on your notes now. So let's go ahead and take a look at example 1. All right, where we're going to use some of these properties of an isosceles trapezoid. So the first thing here is I want to find this length for PS. So I'm going to go ahead and just mark that as an X because I can see that there are no other variables in what I'm given. All right, I'm given that all of RT is 24.1. 24.1. So this whole segment is 24.1. Okay? I'm also told that QP is 9.6. So the first thing I want you guys to do is to make sure that you are labeling your pictures. All right? It makes things a lot easier when you're looking at this. So what we need to remember is we see that I have 2 parallel sides and the other pair is congruent. So that means that I have an isosceles trapezoid, okay? So if my trapezoid is isosceles, the thing that I know, the property that I know here, is that my diagonals are congruent. So I know that QS and RT are going to be the same length. So QS is going to be QP plus PS. This whole thing is QS. So that'll be 9.6 plus X is QS. All right, RT is that 24.1. So basically all we're doing is taking that 9.6, subtracting it from 24.1, and we're going to get 14.5. So that means that PS has a length of 14.5. All right? So for part B, again, I see that I have a trapezoid because I've got FG is parallel to EH. Now, I want to find the value of Y that would make this trapezoid isosceles. Okay? So when my trapezoid is isosceles, now we're looking at those base angles because I don't have anything about the diagonals here. I have that my base angles should be congruent if I want my trapezoid to be isosceles. So that means that the measure of angle E should be equal to the measure of angle H. So we're going to plug that in. I'm going to do 2y squared minus 25 is equal to y squared plus 24. 24. So what I want you guys to realize here is that we have y squared on both sides, but I don't have a y. So we're just going to solve for y squared. So I'm going to subtract y squared from both sides. I'm going to get y squared over here. So that'll be y squared minus 25 equals 24. Add 25 to both sides. We're going to get y squared is equal to 49. So now we need to square root both sides because remember, a square and a square root are opposites of each other. All right. So we're going to square root both sides and get that y is 7. And that will make my trapezoid isosceles. All right. If you have any questions about that, make note on your notes now. The next piece of information that we're going to look at for trapezoids is midsegments. So just like the midsegment of a triangle was a segment that connected the midpoints of the triangle. So if you'll remember, it looked like this. And we had those midpoints and they were connected. Okay. It's going to be the exact same concept. Okay. A midsegment is still going to connect midpoints. But the key here with a trapezoid is that it is the midpoints of the legs. All right. We do not have a midsegment going the other way. So a triangle, we had 3 midsegments that connected each pair of sides. With a trapezoid, we only have one midsegment, okay? And that midsegment, again, connects the midpoints of the legs. So what I know about that midsegment is that it is parallel to the bases. So my parallel sides, I'm making that parallel to the other two. And it's half the length of the sum. What I want you to do here, and actually you'll see it already written in your notes, so you don't actually have to write this down, is you'll see where it says sometimes it's easier to do 2 times the midsegment is equal to the sum of the bases. So sometimes you will see me write this as 2 times the midsegment is equal to base 1 plus base 2. All right, does that make sense? So when we're looking at midsegments, okay, twice the midsegment is the sum of the bases, or half the length of the sum is the same as the midsegment. Either way, and again, sometimes it works better in one situation to use this. Sometimes it works better to double the midsegment. I find that this almost always works better. It's just a little cleaner, and we're not worrying about the fractions. So it's kind of nice that way. All right, if you have questions on that, go ahead and write it down, and we're going to go ahead and do an example. So let's take a look at an example using my midsegments, okay? So for this one, I want to find the length of ST. Notice MN is 31, RU is 38, so there's no variables in here, so I can go ahead and just set XT is equal to X. So what I'm going to do is, again, I like to set up 2 times my midsegment is going to be equal to the sum of my bases. Okay, so my midsegment here, again, I've got midpoints over here because these are congruent. I know N is a midpoint because these are congruent. Okay, so my midsegment has a length of 31. And my bases are going to be X and 38. So 2 times 31 is going to give me 62. And then I'm going to go subtract 38 from both sides to get that 24 is equal to X. So that means that ST has a length of 24. Now, if I change this and I come up here and I write 24, I want you to look and see something. Okay? The difference between 24 and 31 is 7, right? 24 plus 7 is 31. If we look at the difference between 31 and 38, it is also 7. That will always be true. Now, will it always be 7? No. But this difference in base to midsegment and then midsegment to the other base will always be a consistent number. It could be you're adding 5 both times, or you're adding 10 or 192, whatever. But that distance will always be the same amount of change between the bases and the midsegment. All right, so let's do another one. Again, we're going to set up that 2 times the midsegment is equal to base 1 plus base 2. So my midsegment this time is 2x plus 4. My top base, and remember, when we're adding, it doesn't matter which one we use for base 1 and which one we use for base 2. They're completely interchangeable. All right, I just usually do top is base 1 and bottom is base 2, or usually like left is base 1 and right is base 2 if it's on its side. Okay, but either way, it doesn't matter. So base 1 is 2x minus 4. Base 2 is 3x plus 2. So we're going to combine or distribute here first. Do not forget to multiply to both pieces. So this is going to be 4x plus 8. And then I have 2x and 3x to get 5x over here. -4 plus 2 is -2. Okay, so I end up with 4x plus 8 equals 5x minus 2. Subtract 4x from both sides. I'm going to get 8 equals x minus 2. Add 2 to both sides. I get 10 is x. So the key thing here, again, is to go back and make sure you are looking at what the question is asking you. Okay, I want to find the length of MN, not just x. So MN is my midsegment, so it's going to be 2 times 10 plus 4. 2 times 10 is 20, plus 4 is 24. So MN has a length of 24. If you have any questions on that, go ahead and write them down now on your notes. So what I would like for you guys to go ahead and do right now is to do these 3 on your own. So if you would please pause your video, work these 3 out, and then we'll go through the answers. So please pause your video now. All right, so let's go ahead and check your answers here. So for part A, we want to find the measure of angle F. Well, we know that E and H are going to be the same because they are my base angles, because it is an isosceles trapezoid. And remember that these angles here are same side interior angles, so they are supplementary. Okay, so I know E and F are going to add to 180. I subtract 49 from 180 to get 131 degrees. For part B, we're using the fact that my diagonals are congruent. I'm given JN is 10.6 and L is 14.8, so we add them together to get JL. KM will be the same as JL. All right. And then for part C, we have base angles are congruent. So again, we're going to set these equal to each other. Solve for x. Don't forget you need to square root to undo a square. To get that, x is going to be 4. All right, if you have questions about this, go ahead and write it down now. All right, so let's look at 2 more that I would like for you to do on your own. So again, please go ahead and pause your video and do these 2 on your own. All right, go ahead and check your answers here. Again, remember that we're going to double our midsegment, set it equal to the sum of our bases. So here, because there are no other variables, we can call EH x. All right, do 2 times 16.5 will equal x plus 25, solve for x. Here we're going to do 2 times 12t is going to equal 16t plus 10, and then solve for t. Okay, we want the length of the midsegment in part E, so remember we need to plug that back in. All right, if you have any questions, please write them down now, and I hope you have a fabulous day.